What if the real problem isn't that we don't get enough rain, but that we lose it too fast? In some of the driest places on Earth, people solved that problem thousands of years ago. Not by bringing in more water, but by changing how water touches the land. No pipes, no pumps, no irrigation timer. Just dirt, shaped with intent. And the strange part is this. The method looks almost too simple to matter. A small curve in the ground, a low ridge of soil, a basin shaped like a half moon. But in dry country, that shape can decide whether rain disappears in minutes or stays long enough to grow food. Picture a hard landscape after a rare rain. The clouds finally open, and almost nothing good happens. Instead of soaking in, the water runs off. It strips soil away and leaves the land drier again. So the real problem was not always too little rain. Often it was rain that arrived too fast and left too fast. Traditional farmers in African drylands built simple earthworks to solve exactly that. Shallow basins, curved ridges, repeated across the land. They didn't chase water across the landscape. They slowed it down exactly where plants needed it. And once runoff slows down, everything changes. Water settles, sediment drops, the soil gets a chance to drink. What looks like a simple scoop in the ground is really a way of giving rain more time. 14. 10 more seconds. 30 more seconds. One place where water cannot escape immediately. That alone can create a huge difference between a dry surface and moisture stored below ground. And this is the part many people miss. These systems do not create water. They change water behavior. That is why the method is not primitive at all. It is hydrology without plastic, physics without a pump. The basin catches runoff. The ridge slows escape. The soil gets more time to absorb. And when moisture goes deeper, roots do what roots always wanted to do. Follow it. That is why this matters beyond farming. It is really a story about design. Most people think water problems are solved by bringing in more water. Old dryland systems asked a better question. How do we lose less? So how would you use this now? Start smaller. Watch your slope. Watch where the water runs. Instead of leaving the ground flat, shape it. Create small basins. Use curved ridges. Plant where moisture will collect. Add mulch or organic matter, and the effect gets even stronger. Now you are not only catching water, you are helping the ground keep it. So the hidden secret was never about getting more water. It was about not losing it, and shaping the land so rain finally has a chance to stay. So the older electrical theories slipped out of mainstream agriculture. Not because every question behind them was proven foolish, but because they were no longer the center of the system. And for a long time, that was where the story stayed. A strange historical footnote. Until now. Because the most interesting twist in this story is not that passive copper stakes have suddenly been proven right. They haven't. The interesting twist is something else. Modern science has returned to a nearby question. Not exactly the same question, not with the same tools, not with the same assumptions, but nearby. The old electroculture world asked whether plants might respond to electrical or energetic conditions around them. And today, researchers are again studying ways that controlled physical energy treatments can influence seeds, water, and plant development. That is where cold plasma enters the story. Cold plasma sounds futuristic, but the basic idea is easier to understand than the name suggests. Plasma is often called the fourth state of matter. It is an energized gas containing reactive species that can interact with surfaces and biological materials. When used in a controlled way, cold plasma can change the surface properties of seeds. Research reviews describe improvements in wettability, water uptake, and, in many cases, germination behavior and seedling vigor depending on crop species and treatment conditions. Plasma-activated water is also being studied because it can carry reactive nitrogen and oxygen species that may affect plant growth and development. That is the part where the old story becomes unexpectedly modern. Because now we are no longer in the world of vague promises. We are in the world of controlled exposure, measured parameters, repeatable protocols, and published results. Seeds can be treated for specific durations. Water can be activated under defined conditions. Responses can be measured in germination rate, emergence, seedling vigor, stress response, and growth behavior. Does that mean science has proven the old copper spiral videos right? No. And this distinction is one of the most important parts of the entire topic. Passive electroculture, the kind shared in popular gardening spaces today, is not the same thing as modern cold plasma treatment or other controlled electrical methods. A passive copper rod in the soil is a very different claim. And when modern passive versions have actually been tested, the results have not supported the biggest online promises. That doesn't ruin the story. It actually makes it better. Because the real story is not, old magic was proven true. The real story is that early experimenters may have sensed a real category of question, but they did not yet have the tools to answer it properly. That is far more interesting than either blind belief or lazy debunking. The early electroculture world was trying to understand whether plant growth could be changed by forces beyond simple chemical feeding. That instinct was not completely absurd. Plants do exist inside physical systems. They respond to light intensity, to wavelength, to water availability, to temperature, to humidity, to oxygen around roots, to the chemistry and conductivity of their environment, to the behavior of microbes around them. So the broad intuition that growth is not just add more nutrients was not wrong. Where things became unstable was in the leap from plants respond to physical conditions to this copper spiral definitely increases your harvest. That leap is exactly where so many garden myths are born. A good question starts the story. A weak method distorts it. A beautiful image sells it. And soon the idea is stronger in people's imagination than in the evidence. Electroculture lives in that zone. It survives because it offers something people deeply want. A simple hidden lever, a low-cost shortcut, a non-chemical secret, a feeling that nature still contains buried knowledge that modern systems ignored. And honestly, that desire makes sense. Because modern agriculture and gardening really do often reduce everything to products, inputs, and purchases. So when a theory appears to say, maybe the plant needs a better environment, not just more chemicals, people listen. And they should listen. Just carefully. Because this is the useful takeaway. The passive copper rod may not be the breakthrough, but the deeper question still matters. What actually drives plant performance in the real world? Is it always nutrient shortage? Or sometimes poor root zone conditions, weak soil structure, inadequate water dynamics, damaged biology, temperature stress, poor seed vigor, missed physical signals that shape early development? Those are real questions. And modern research into cold plasma and plasma-activated water suggests that physical treatment before or around growth can matter under the right conditions. even if the internet version of electroculture oversimplifies the whole thing. So was electroculture a lost revolution? Probably not. Was it complete nonsense? Also not quite. It was something more complicated. A long historical attempt to understand whether plants respond to energy and electrical conditions in ways farmers could use. Some of those attempts were clumsy. Some were serious. Some results looked promising. Some did not hold up. And the modern, passive, copper-stake version has not earned the confidence its biggest claims demand. But the story still matters, because it reminds us that science does not always move in a straight line. Sometimes an old idea is wrong. Sometimes it is early. Sometimes it is partly right for the wrong reasons. And sometimes the first version of an idea fails, while a later version becomes real. That may be the most fascinating part of this whole arc. Not that people once tried to power plants, but that their strange old question never completely disappeared. It waited, and when science finally came back to it, the answer did not look like a copper spiral in a tomato bed. It looked like plasma. So maybe the lesson is not that the old gardeners found a miracle. Maybe the lesson is that they were reaching toward something they could not yet measure. And now, centuries later, we finally can.